Okay, this is going on page 128 when we're done. What we're going to do today is we're going to look at the types of symmetry that exist in polar curves before you really know what all the polar curves really look like and what the purpose is and all that kind of stuff. Because I want to look at it algebraically before we actually look at the graphs. Tomorrow I'm going to give you a graphic organizer that has all of what's considered the classic polar curves on there, and their symmetries and some more information about them. Eventually, you should be able to look at an equation like what is on number 1 here and know which curve that goes with. Not necessarily exactly just graph it right then, but, like know which one it is, kind of like your parent functions, okay? So if I gave you, x squared plus or 3x equals y, then you know it's going to graph a parabola, right? That kind of thing. In pre-cal, I'm not going to expect you to just know them, but you should be able to match them up on the graphic organizer and start to learn them. Eventually, you're going to look at that and you'll know exactly what it is and what to do with it, but this is all still kind of fresh, so that's a little much to do at this point. So even though we're looking at the symmetry and you don't even know what this graph looks like, that's kind of the point I want to make with this, is you don't know what this looks like. It could be, even if it has the type of symmetry that they're talking about up here, it may not actually look like this, it just has that type of symmetry. But understanding the symmetry of the curves is going to help you when you're graphing them and when you're finding area within them and all the other kinds of things you're going to do with them in the future. All right, so we're just going to look at them, the symmetry here. So this first curve is symmetric to the line theta equals pi halves. That's like your y-axis in your rectangular coordinate system. This one is symmetrical to the polar axis, which is like your x-axis in your rectangular coordinate system. And this one is symmetric to the pole, which is like the origin symmetry that has, you rotated 180 degrees. So when we looked at this stuff algebraically on the rectangular coordinate plane, way back when, this was on page 31 in your ISN. So that was, like a lifetime ago. Oh, you can't even see it, but it's page 31. So when we tested for symmetry to see if it was symmetric to the x-axis and not go by looking at it, we substituted in a positive x, negative y, simplified it, saw if we got the same thing we originally had. Remember that? And then we substituted in negative x, negative y to test for y-axis symmetry, and I'm sorry, negative x, positive y, and then negative x, negative y for origin symmetry. So we have the same kind of rules for polar. Obviously, they're different than this, and they're not x and y, but we're doing the same type of thing. So you've done it already for rectangular coordinates and rectangular graphs. We're going to do it now for polar graphs. So here are the rules that go along with it. And so it says a graph of a polar equation has the indicated symmetry if the following replacements yield an equivalent equation. Meaning after you substitute it in, then you simplify it out, see if you have the same thing you started with. So instead of just having like a negative x, positive y, we have two options for each because there's more than one way to get to a polar point. So I'm going to start off with the first ones here. So if I want to see if it has symmetry with respect to the line theta equals pi halves, then I would substitute in a negative r, negative theta, or, and I'll give you the ors in just a minute. For a polar axis, I would substitute in the r negative theta or something else. And then for pole symmetry, I would substitute in a negative r theta. Okay. So since I have more than one option here, then for the theta equals pi halves, it's either negative r, negative theta. So let's say that I substitute this in, it doesn't match. Then I have a second one I have to try before I move on. If I get a yes here, then I don't have to try the second one, okay? So the other option that would tell me that I have this kind of symmetry here is r, positive r, comma, pi minus theta. The second option for polar axis is negative r, pi minus theta. And then the second option for pole symmetry is r, comma, pi plus theta. Now, when you tested for symmetry for on the rectangular coordinate system, you were expected to know if it was y-axis, whether you did negative x, positive y, or positive x, negative y. Here, especially because you have two options and just like everything else, it's the same thing over and over again. The signs just change and it's really easy to get all that mixed up, right? So for right now, this is something that I would give you, right? Like I'm going to tell you this even on a test or a quiz, and then you just have to use it correctly. And again, eventually you'll just know what it is and it won't be that big of a deal. But right now with all this stuff being new, I know it's all kind of new and weird. And all I really want to make sure you know how to do is how to use it correctly. Not that you have all this memorized, because you know, it's not that important that that's memorized. So it says use polar symmetry test to determine if the types of symmetry. So you have to test them all. Even when you get a yes, you have to test the next type because you could have more than one type of symmetry. So let's start with, on this equation here, we're going to start with the theta equals pi halves. Right? So to test that, the first test is to substitute in a negative r. So negative r equals 2 plus 2 times cosine of negative theta. So I substituted in a negative r and a negative theta, and then I'm just going to clean things up. So this means that negative r equals 2, and then plus, what's cosine of negative theta? Cosine theta. So this is really just 2 cosine theta. Then to solve for r, this is going to give me r equals negative 2 minus 2 cosine theta. And that's as cleaned up as it gets. Does that match my original? No. So this is a big no here. So I can't move on to the next type of symmetry until I use the second option I have for this theta equals pi halves. So now I substitute in a positive r. So r equals 2 plus 2 times cosine of, and this time it is pi minus theta. And then I got to clean that up. So when I get to this pi minus theta, do I just distribute my cosine? No. According to some of you on the test, that's the way to do it, but no. So r equals 2 plus 2 times, what do I do with that? How do I know what to do with that? Yeah, use the cosine thingy. Where do I find the cosine thingy? It's on the chart. Yeah, that's like cosine of a minus b. So find it and write that out. The big blue card that I gave you is the one that it's on. Like the 5th version I gave you. It's also in your notes somewhere, but it's probably easier to find on that. All right, so since it's a cosine one, that means we got cosine, cosine, and then the signs are opposite. So this should be cosine pi times cosine theta, then plus sine pi sine theta, right? So if you don't know what it is, which that's fine if you don't, but you got to know where to find it and what to do with it. Everybody good so far? So I don't want to distribute that 2. I'd rather clean up what's in the parentheses first. I mean, you could distribute the 2, but I'm not going to do that. So it's 2 plus 2 times. All right, what's the cosine of pi? Negative 1. So cosine of pi is negative 1. So this is negative cosine theta here. Plus, what's sine of pi? 0. So it's 0 times sine pi, which is 0. So that means I get r equals 2 minus 2 cosine theta. Is that the same as what I started with? No. So this is a no also. So since I got 2 no's, that means we do not have symmetry with respect to the line theta equals pi halves. So then we move on and we check the polar axis. So to check polar axis symmetry, we substitute in a positive r and a negative theta. So this would be r equals 2 plus 2 cosine of negative theta. So r equals 2 plus, what's cosine of negative theta? Cosine theta, so plus 2 cosine theta. And I have it simplified as much as possible. Does that match what I had? Yes. So this is a yes. If I can write yes, there we go. And so I have polar axis symmetry, which means I don't have to check the second version of the polar axis symmetry because I already say that it's yes. So then I move on and I check pole symmetry. So for pole symmetry, I substitute in a negative r and a positive theta. So negative r equals 2 plus 2 cosine theta, which means that r is equal to negative 2 minus 2 cosine theta. That's the best I can do. Is that the same as the original? No. So then I got one more thing to check. Got to substitute in positive r and then pi plus theta. So r equals 2 plus 2 times cosine of pi plus theta. All right. So that means r equals 2 plus 2 times, so it's a cosine, which means it's cosine pi, cosine theta. For cosine, the sign's opposite, so it's minus sine pi, sine theta. All right, so what's the cosine of pi? Negative 1. So this is negative cosine theta again. Minus sine of theta is 0, so the minus 0 really doesn't do anything. So I end up with r equals 2 minus 2 cosine theta. Does that match? No. So we have polar axis symmetry only. Any questions at this point? No? Okay. All right, good. So we are going to skip number 2 for right now. We're going to come back and do part of number 2, but not all of it. We're going to go on to number 3. So I have this graph that I don't know what it looks like, but I can check the symmetry here. So I'm going to start with theta equals pi halves. So to test that one, I substitute in a negative r and a negative theta. So negative r squared equals 9 times the cosine of 2 times negative theta. We're on number 3. Make sure you're on number 3 and not on number 2. I skipped number 2. So what's negative r squared? R squared. So r squared equals 9, and then cosine of a negative theta is cosine theta. So this is cosine of 2 theta then. Does that look like what we started with? Yes. Okay. So this is a yes, and we have this symmetry here. So then we check the next one. I don't have to do the second version of that, but I move on to the polar axis, which means for polar axis symmetry, I substitute in a positive r and a negative theta. So that's going to give me r squared equals 9 cosine of 2 theta, right? So the answer is yes. Then for the last one, for the pole symmetry, I substitute in a negative r and a positive theta. Now, before you ever even substitute it in, do you kind of already know what's going to happen? Yes, but you still have to do it, because that's the purpose of this, is showing it. Now, in the future, if you're just using it to figure out if it has symmetry, to use it for a graph, that's different. But here, when you're supposed to be showing it, improving it, even before you substitute it in, if you know what's going to happen, you still have to, you don't have to do 1,000 steps, but you still have to substitute it in and then show that that's what you get. Okay. And so this is a yes also. And we have all 3 of them. Okay. Easy enough? You understand the process? Okay. I don't think we need to do every single example, but I do want to do part of number 3 because just so the way a couple of things work out. So we're going to just start number 3, number 2, I'm sorry. We're going to start number 2, but just know that I'm not finishing it. So like when you go back and look at your notes, don't think it was okay just to do part of it here or something like that. So we're just going to start it like normal. We're just not going to do all of it. So we're going to start by checking theta equals pi halves. Right? And so in order to do that, I'm going to substitute in a negative r and a negative theta, right? So negative r equals 1 minus 4 times the sine of 4 times negative theta. So I get negative r equals 1 minus, all right, so what is the sine of a negative theta? Negative sine theta. So this 4 right here, it just doesn't really do anything, but the sine of the negative theta is negative sine theta, so this, since it's minus, becomes plus, and so this is plus 4 sine of 4 theta. Does that make sense? Make sure you understand what to do with those negative thetas there. So then this gives me r equals negative 1 minus 4 sine 4 theta. That is not what we started with, so that's a big no. Okay, everybody good with that? Now, we're going to go ahead and do the second part too, because something else that happens there as well. So to try the second part of the theta equals pi halves, we substitute in an r and then pi minus theta. So this is going to give me r equals 1 minus 4 times the sine of 4 times pi minus theta. So we really have brackets here, right? Because it's the sine of that whole mess right there. We have sine of a minus b on our chart, but we don't have the sine of that on our chart, right? So we need to fix this into something that we know how to do, which means all you're doing is the thing you're taking the sine of, this, that we're taking the sine of. We're just this is just regular old stuff, and we can just distribute that 4 in there. So we get r equals 1 minus 4 times the sine of 4 pi minus 4 theta. Does that make sense to you? So now I have the sine of a minus b. You good? All right, so go ahead and substitute in off of your chart for that. So r equals 1 minus 4 times, and then fill that in. Is that what y'all got? Sine of 4 pi cosine 4 theta minus cosine 4 theta minus cosine 4 pi sine 4 theta. We're good? Okay. So then r equals 1 minus 4 times. All right. What is the sine of 4 pi? Where's 4 pi on your unit circle? It's 0, right? So the sine of 0 is 0. So this is 0 times the cosine of 4 pi, so that whole thing just becomes 0, minus, what's the cosine of 4 pi? 1. So it's minus 1 times the sine of 4 theta, which means I get r equals 1, and then that negative sine of 4 theta times the negative 4 is going to be plus 4 sine of 4 theta. And that's a big no also. Everybody okay with that? And so obviously you'd have to continue on this problem. The problem is not finished, but I wanted you to make sure you knew what happened when you get sine of a negative theta and what happens when you have a number in front of your theta, how to handle that. Okay, are we good? Any questions? So you should have lots of time to work. Make good use of that time. I'd rather you have the time to work through the algebra of this instead of me just doing all of them for you.